Okay, good morning, everyone. My name is Stefano Dallaglio. I am one of the team members at the Venice Center for Digital and Public Humanities at Foscari, University of Venice. It's a real pleasure for me to introduce my colleague, Deborah Paci. But before that, I want to give you just a few practical informations. First of all, well, keep in mind that this session is going to be recorded, but you're not going to appear in the recording unless you keep your video open and speak with your video on. Otherwise, you're not going to appear. The other thing is that, well, please remember to keep your microphone on mute, just to avoid any background noise. But I can do it for you if you forget. Okay, so that's more or less it. Please remember that you can write some comments or questions in the chat, but questions are not going to be asked before the end of the talk. And now I'm going to introduce Deborah Paci. Deborah is a contemporary historian and teacher of digital history at Ca' Foscari University. Her main research interests focus on public and digital history, intellectual history, and island studies. She is currently working on Odysseus, historical study case, French anti-Semitism 1718-1918, which is part of the international research project Odysseus, Opinion Dynamics and Cultural Conflict in European Spaces. She uses network analysis and topic modeling methods to study the social cultural categories that supported the anti-Semitic movement in the 1880s and 1890s. Today, she's going to talk about networks and history, methods and tools for visualizing historical data. Deborah, the floor is yours.
Thank you so much for this very kind introduction, Stefano. Hello, everyone. So what I'm going to tell you today is the overview on methods and tools for visualizing historical data. Firstly, I'm going to discuss briefly challenges and opportunities that network analysis provides for historians. I'm going to talk to you how network analysis can be used for historical purposes, and importantly, network analysis can add value. Second, I will provide hands-on experience to those interested in learning about the potential of network analysis. So I will talk about Palladio, that is a free web-based data visualization platform that is currently in development at Stanford University's Humanities Plus Design Lab. So let me go ahead and share my screen. Okay. The best known project concerning network analysis applied to historical research is this project from Stanford, Mapping the Republic of Letters. Researchers at Stanford decided to choose several figures as paradigmatic case studies, mapping all of the extant correspondence of Galileo, Voltaire, John Locke, and others. Basically, this is looking at letters that were sent between various important thinkers during the Enlightenment, and using those letters as evidence of the kinds of networked relationships that we are going to talk about today. As we will see, the software that these researchers initially developed just for this project, Palladio, is now available more broadly. So scholars can come and bring their own data and generate some of the kinds of visualization that they have in mapping the Republic of Letters. And so that's also worth checking out if you are new to network analysis, if you are interested in getting started in network analysis. Palladio is a very user-friendly software for approaching the field of the network analysis. So turning our attention now to the networks in history. I am a digital historian interested in applying network analysis to my own work. So what I'm going to tell you today is an introduction to network analysis. So the developing field of network analysis has shown the power of this type of modeling for highlighting relationships, which can not only highlight the major actors, but also illuminate important lesser known actors within networks. So network analysis algorithms allow examination of and focus on figures that may be important hubs or connectors in networks that have remained invisible or only hinted at with traditional methods. Network analysis methods reveal a wealth of data about individuals and their importance in a network based on their relationships, using, as we will see, analytical measures as betweenness and eigenvector centrality. In addition, network analysis can expose the infrastructure of networks as well as the strength of ties between individuals in the network. So we can say that often these methods can make the invisible visible. If we are going to talk about networks, we have to get some really basic terminology. We have to share some terminology and we can talk about what this means specifically when we are talking about humanities networks. So how should we think about networks? In the most basic sense, a network is any collection of objects in which some pairs of these objects are connected by links. So this definition is very flexible. Depending on the setting, many different forms of relationships or connections can be used to define links. Now we're going to explain, I'm going to explain basic ideas behind graph theory. Graph theory is the study of network structure. So, but it needs to know that there is also the game theory that provides models of individual behavior in settings where outcomes depend on the behavior of others. Actually, there are numerous settings in which a group of people must simultaneously choose how to act, knowing that the outcome will depend on the joint decisions made by all of them. So game theory is designed to address situations in which the outcome of a person's decision depends not just on how they choose among several options, but also on the choices made by the people they are interacting with. A graph is a way of specifying relationships among a collection of items. A graph consists of a set of objects called nodes, with certain pairs of these objects connected by links called edges. So there are two primary components to any network graph, and the first is nodes. So nodes are sometimes circles, they are sometimes squares, that depends on the visualization software, but essentially nodes are the entities. So these are the things that you want to represent in your network, and depending on what your network is, they can be all kinds of different entities. They could be people, they could be organizations, they could be locations, they could be books, they could be text, they could be words. So we have our nodes, these entities, and then between them we have what are called edges, or sometimes links, when the edges represent the relationships among the nodes. For example, the graph in figure A consists of 4 nodes labeled A, B, C, and D, with B connected to each the other 3 nodes by edges, and C and D connected by an edge as well. So we say that two nodes are neighbors if they are connected by an edge. Figure A shows the typical way one draws a graph, with little circles representing the nodes and a line connecting each pair of nodes that are linked by an edge. In figure A, you should think of the relationship between the two ends of an edge as being symmetric. So the edge simply connects them of each other. So it's a directed network. So a direct network is a network in which the edges are directional. When A sends, for example, A sends a letter to B. In many settings, however, we want to express asymmetric relationships. For example, that A points to B, but not vice versa. For this purpose, we define a directed graph to consist of a set of nodes, as before, together with a set of directed edges. So each directed edge is a link from one node to another, with the direction being important. So directed graphs are generally drawn as in figure B. Sorry, in a figure A, we have a undirected network. So, on the contrary, directed graphs are drawn as in figure B, with edges represented by arrows. So when you want to emphasize that a graph is not directed, we can refer to it as an undirected graph. But in general, the graph we will discuss here will be undirected. Undirected. So, for example, if you think about Facebook, a friendship is what we would call an undirected edge, because it's mutual always. For example, if John sent me a friend request and I accept it, then we are now friends. It doesn't move in any one direction. It moves essentially in both directions, and it's equal. A directed edge implies some kind of direction, whether that be authority, whether that be movement. If, on the contrary, if you think of something like Twitter, we might decide that Twitter following and on Twitter is a kind of directed relationship, because I can follow John and he can choose to not follow me back. So nodes can have attributes. Each node, for example, may include the title, the number of pages, the year of publication. Nodes can include metadata stored in a key value pair. For example, let's say there are two friends, John and Paul, who met on the 24th of January in 1956. In this case, the nodes may be John and Paul, with metadata stored in a key value pair as ID. And age, the friendship is represented as a line between the two nodes. So it's a undirected relationship. So we may have metadata such as date, which represent the date on which John and Paul first met. The other thing that we want to know about ages is that they can be weighted. And what weighting means, again, depends on exactly what we are trying to represent. For example, thinking about a network of letters being sent, we might decide that these are directed relationships. So I send a letter to John, so that's an age from me and from me to John, and that every time I send a letter to John, the age becomes slightly stronger. The weight increases, and so then you could imagine, for instance, that perhaps I send I send 15 letters to John. He sends me one back, so there is a strong relationship in only one direction and a weaker relationship in the other direction. Another another aspect very important in network analysis refers to centrality. Centrality finds how central or important each node is in a network. So centrality of a node is a numerical measurement of importance of a node. Degree centrality is a simple example. So there are four types of centrality. Degree centrality, that is the number of connection. This is the number of edges connected to this node. Variants include in degree out degree, which counts the number of ingoing and outgoing edges in a directed network. Sometimes indicated by the sides of the sphere representing the node. So centrality is very important because it's generally used to determine how important nodes are in a network. For example, centrality can be the amount of influence or power someone has. So the simplest way of measuring node importance is to just look at its degree centrality. If, for example, if we are looking at the social network of Facebook, with every person a node connected by an age to their friends, it's no surprise that the most well-connected person is probably also the most powerful or influential in the social space. Second, closeness centrality. Closeness centrality is the closeness to the entire network. Closeness centrality measures the proximity of a selected node to all other nodes within the graph. So it's calculated by getting the average distance a node has to each the others, and then taking the reciprocal. Then betweenness centrality. It's very important. Betweenness centrality is to what degree a node provides a bridge to other nodes. Betweenness centrality is the number of the so-called shortest path in the network that flow through a node or edge. For example, a node X has a high betweenness centrality if the shortest path from Y to Z is through X. Finally, eigenvector centrality. This is the connection to well-connected nodes, bridging nodes. So eigenvector centrality measures the influence of a particular node by the connectedness of its closest neighbors. Well, in visualizing network relationships, one of the first and perhaps most difficult challenges is to decide who should be part of the network and which relations between the selected actors are to be coded. It will probably take some time to figure this out, and will likely be an iterative process, since you will need to balance your research interest and hypothesis with the availability of information in your text, and then represent both in a rigid and necessarily simplifying coding scheme. So the main questions during this process are: what defines a relationship between two persons? Who is part of the network? Who is not? Which types of relationships do you observe? Which attributes are relevant? And what do you aim to find? So the translation of text interpretation into data collection as its root in sociological qualitative data analysis. So it's important that you that you and others can retrace your steps and understand how you define your relations. So it's very helpful to define them abstractly and provide examples from your sources to further illustrate your choices. So any data you produce can only be as clear. It's very important, clear and coherent, and as your coding practices. So clarity and coherence increase during the iterative process of creating coding schemes. So the process of designing such a coding scheme forces you to become explicit about your assumptions, about your interests, and the materials at your disposal, something available beyond data analysis. Another side effect of extracting network data from text is that you will get to know your sources very well. Because sentences following the model, person A is connected to person B, C, and D through relation type X at time Y, will probably be rare. Instead, it will take close reading, deep context knowledge, deep historical context, and interpretation too, in order to find out who is connected to whom, in which way. So this means that coding data in this way will raise many questions and will force you to study your sources more deeply and more rigorously than if you had worked through them by using the traditional way of analysis. Now we are going to be taking a look at a tool called Palladio. Palladio offers several views, network graphs, maps, timelines, table, and galleries. It's very important for public history purposes. So Palladio is an analytic tool for looking at historical data across time and space. I tend to think of it as a historical viewfinder. Palladio is a web-based platform that allows humanities scholars to very easily upload the data and explore it through a variety of visualizations. It allows to visualize data as a part of the research process. So I think that it's a project in which there is a great interplay between designers, developers, and scholars. So all tools has been built actually to accommodate the ways humanities work or could work with data and technology. So here on the initial page, you immediately realize the different possibilities. You create your project, as we will see, by uploading, and there are different ways of uploading your data, and then you can have a view that can be a map view. You can add a list view of your data, gallery view. You can filter your data either in a timeline or in a time span, or use a phased filter, and of course, at the end, save and export. So the big challenge is precisely thinking about new tools which are able to integrate these two aspects, which are the aspects, so that data driving insights versus human experience, human knowledge. So what Palladio provides is the opportunity to create a natural graph in which you have the possibility to use two different, for example, two different kind of nodes in networks and inter-network analysis. So what you see is a network in which you can connect the places and institution, organization, or many other categories, and see, and it's very important, see if patterns or clusters emerge from that. So when might Palladio be the right tool for you? You have structured data. Here, structured data means data in a spreadsheet. So categorized, sorted, and stored in an Excel document, and or some kind of spreadsheet application. It's good, right tool for you. If you are interested in time-space relationships, because Palladio shows you how various entities are connected across time and space. And it's good for you if your data has many attributes, because Palladio is really good at helping you uncover relationships among disparate attributes over time and space. On the contrary, when might Palladio not be the right tool for you? It's not good if you have unstructured data. If you are trying to analyze, for example, a long text, like a poem or a novel, Palladio or monograph, I don't know. Palladio won't help you much. You will want to look for text and for text analysis tool. I don't know, like for example, Voyant. I don't know. So it's not good if you just want to count things. If you just want to make relatively simple charts and graphs, Palladio is too much tool for you. Instead, you can try using I don't know, Excel's built-in function or and so on. It's not good for you if you want to present an interactive visualization, because one big limitation of Palladio is that you can embed or share the visualization you create, except in a static form. So while Palladio is very good because it can help you explore and understand your data, it's not great for presentation. At least not yet. Instead, I don't know, you can try using Google Fusion Tables or Tableau. It's not good if you want to create complex fine-tuned maps and networks graphs, because while Palladio can produce maps and network graph, you cannot customize them to any great extent, and then you cannot perform sophisticated network analysis. I don't know, such as calculating various measures of centrality, you know, eigenvector centrality, for instance. Instead, you might consider more sophisticated mapping tools as JFE or Citoscape. Finally, it's not good if you hate bugs, because Palladio is still young. You will encounter some bugs. If you prefer not to use unstable software, you might investigate other tools. So, because Palladio is very good, because Palladio is a digital visualization, it's a digital visualization tool developed by the scholars at the university. Stanford University, Humanities and Design Lab at Stanford University. Okay. Well, so I will we can access to Palladio. It's the home page. You can type on Google Palladio Stanford. Okay, perfect. So I will be using my data sets just as an example to try to show you how Palladio works. The data set is about Fausto Gullo correspondence. Gullo was an Italian statesman, Minister of Agriculture and Forestry, and the Minister of Justice in the second half of 40s in Italy. To start, we'll go to the website Palladio Stanford, and we will hit start. The first thing that it will ask you to do is to upload your data. So the easiest way to do this is just in a spreadsheet. Think that's very important. So make sure that your data is consistent. Unfortunately, my data set is not consistent, but it's just a simple sample data. However, I will show also a sample data provided. You see. By Palladio. So Palladio can be a little bit exigent on particular data points, in particular dates and coordinates. As we will see, Palladio allows you to combine multiple data, multiple data sets together. So my data set. Okay. It's about individual person. Okay, we have the names of individuals when they were born, when they died. If there is a specific date, I will enter that, and the birthplace of these people. If there is a particular title of position, and then I get into the plot of the program. You will see that there is an option called gallery mode that can help you. So you can go through and display various points of data. At least for me, what I want, as we will see, what I want to do is use that gallery mode to just show little pictures of each of these people. So I have included in my dataset links to pictures of these individuals, a small description of who they are and why they are significant for this time period, and then you see a link to their Wikipedia page. So what we are going to do now, that is, we are going to upload the data set into the Palladio program. At this point, especially if you have different or multiple data set, Palladio suggests that you start with your primary table. I have three data set for the letters, for the person, and the place coordinates. So in this case, that's going to mean my data on the letter. The primary table is Gulo letters. So open spreadsheet. So I'm going to copy and paste that all table, including the column headers. Okay. Sorry. Oh. Just okay. Okay. We are going to copy this into Palladio, and and Palladio will actually format it in such a way where those headers will become the column section as well. So load. Maybe just oh. Okay. I don't know if it's a problem. Okay. It works. So we are going to load that in. We are going to give this table the name letters. We are going to give a title for this project. Okay. Once you put in all this data, anytime you see a red dot, that means that there is something either wrong or something that you have to do in order to solve the problem. One thing that is a little bit problematic in Palladio is that you have to tell the program what you want dashes or commas to mean. In this case, doesn't mean anything. So to get rid of the red spot, first we are going to get rid of those, and we will be done just to make sure that Palladio knows at least for that particular set of data, comma and dashes don't mean anything. So letters. Click done. language is fine. We come to the bibliographic information. Okay. So we have to make sure that the comment is okay there. Subject, same thing. This is when there is a little bit difference in that there are multiple subjects for each letter, and so there are multiple values that can correspond. So, for example, election gullo can show up in a number of places. It's one separate entity. So we are going to put for multiple value, comma, okay, but it's comma that is dividing those multiple value. That's significant here. So click done. Perfect. Mention same thing. So there are multiple names are going to show up, and if there are 6 or 7 names there that are mentioned on one letter, Palladio needs to know that it's a comma that is separating those. So click on comma and done. Letter data, same thing. Done. Perfect. Okay. What we are going to do then is we are going to actually combine and link data between different tables. The way we are going to do is we will start with the author. So click on author. And we are going to extend this part of our table by adding in that person's table from our data set. So we are going to add a new table. Okay. So my Gullo individuals, copy. Okay, no, sorry. Not my mouse. Okay. Okay. Load. Perfect. Done. Okay. So we are going to give this table the name persons. It's the same. So it's being linked to there. So the same thing we have to go here and attend to any of the red dots that show up something here with the comments. Make sure that they are okay. Go click done. Perfect. Title position is a comma down. Description and link. Done. Okay, perfect. Now that we have the persons table established, we will go to the recipient. and the letters table, and we will do the exact same thing. So this is our primary dataset, letters. Click on recipient, and let's use an extension that will link the persons in the letter, the persons in the letters table to the persons table. So choose a table, click on person, click on done. There now one other thing we need to do is we need to add in our third dataset, and that is the locations, the places. So we are going to source location. And we are going to add a new table of information. Click on add a new table. We will do the same thing we did last time. So I have my dataset, Google coordinates. Copy and paste. Okay. Paste. Load. Perfect. Click on done. We are going to give a name, places. We got 6 out of 6 match there. We will call these places. Here it says that it's linked to 6. We will do the same thing with destination location, my primary dataset. Click on destination location, and we are going to use the extension. Choose a table, places. Click on that. And then the only last link that we have to make then is just in mention. So anytime a letter mentions somebody, we want to make sure that recognize that person is also in the persons table. I'm going to show this. Click on subject. Choose a table, person. There are some problems because my data is very poor, but it's the good way. Okay, done. Perfect. So once we have all of our data established, are connected in the ways that we wanted, now we can go to the visualization portion. Okay. This is click on map. This is the map feature. We have done our data. So now we can start to visualize that data in number of different ways for the map. So we are going to click on new layer. The map is really significant in that because it can help show geographically where Gulo and all his letters are going to, and you know how especially geographically how different correspondents are related to each other. So we are going to give the name and correspondence. So click, you can do point to point, trying to show the relationship with what a riding point. Source places. Source places are going to be our source location. So click on source location. Target place is our destination location. Click on destination location. Those are corresponding, it's very important, those are corresponding with the columns in our data set. As well, Palladio has uploaded those for us. The tooltip label is when you scan over the different points in the map. So you can show coordinates or place name. You can choose coordinates or place name, but let's do the place names because that's probably more significant and a little bit more educational. Okay. What we are trying to do here, so we will do place name, okay, color is fine. We will do show links, okay, show links. We select or select. We select, and then we will cite the point as well. So the places that have the most number of letters, according to the number of letters coming out of them, so those will be larger area. So once all these are set up, we can add a layer. So click on add layer. We can also mute. Sorry, we can also mute correspondence. If you want to just clicking the eyeball, open it. Okay, up again. We can zoom. You can see. Okay, you can see how this looks. So this large circle in the middle here, this is Cosenza. This is where Agullo lived, and then all these points, little points, are various places or people of correspondence. So geographically, it's writing to the village of Cosenza area. So that's the map feature. That's one thing. The one thing that we can do through Palladio, you can also a number of different layers. So click on new layer. Click on tiles. You can do different backgrounds as well. So right now we are just doing land, kind of land. You can, for example, do satellite. So click on layer. Okay. You can do different background as well. You can mute land. You can mute satellite. You can remove land, for example. you have different we are different layer. You can add building add street street maps, buildings, areas, terrain. There are some other different cells that are the background as well. So there is a little different thing you can do. So now we will go from there. So the map is the measure way that you can visualize the data through Palladio. This map is not significant because my dataset is poor, but it's important. The next way is the graph. So click on graph. This again shows geographic relationship. It just shows the connection, the correspondences between multiple figures. So the source will be the author. Click on author, close. The author is writing the letter. I like whoever the author is, and the target will be the recipient. Close. And again, these are coordinating all of these dimension of our columns on our data set. So we can see the link, nodes. We can see we can cite the nodes based on the number of a letter, but we can choose to base on the number of person or on the number of place. For example, okay, the number of letters is significant. Now I want to show a network visualization related to the Society of Friends. I will open another. So the Society of Friends, known as Quakers, founded in England in the mid-17th century. The Quakers were Protestant Christians who dissented from the official Church of England and promoted broad religious toleration. Quakers' number grew rapidly in the mid to late 17th century, and their numbers spread through the British Isles, Europe, and new world colonies, especially in Pennsylvania, founded by Quakers leader William Penn. Since scholars have long linked Quakers' growth and endurance to the effectiveness to their networks, the data that I'm going to show you is a list of names and relationships among the earliest 17th century Quakers. This dataset is derived from the Oxford Dictionary of National Biography and from the work of the 6 degrees of Francis Bacon project, which is reconstructing the social networks of early modern Britain. So yes, it's here we have 2 data set, Quaker edge list, Quaker's node list. When you open the node, find the program, you choose of your choice. I will choose use Palladio. You will see that each Quaker is primarily identified by their name. Each Quaker node also has a number of associated attributes, including historical significance, gender, birth date, dates, and an ID that will enable you to cross reference nodes in this data set with the original big data set 6 degrees of Francis Bacon project. I want to just show you the network. So I'm going. We are going to copy and paste. Okay. Click on load. Okay, graph. Choose on name. For example, gender is not significant. ID is the network, but I want to know. I choose the wrong data set, not Quaker's node list, but age list. Sorry. So okay, this is the one. The right file. So Quaker's edge list. We have source and target. Click on start. Click on load. So graph, source, the source, name, target. Okay. So this is the network related to Society of France. Can just side note. Yes. Oh. Okay. We have to put all information because I remove the original project. Just a moment. person. Just a moment. Okay, source location, add a new table. And destination location. Perfect. So, that's the graph portion. Another way to visualize the data is the table, and this actually is just essentially allows us to put all information of our data. So it would be very similar to what we have in our Excel worksheet. Essentially, if you want to show the data that people are working with, that they are seeing on the problem, this is the way to do it. So you have letter ID, choose of the bus row, letter ID. And then what we'll do is we can add other information as well. So we will add the author on the dimension, the author of each letter. We will add the date for each other. Letter date. Okay. We we can order them depending on how we want them displayed. Let's see. Let's add obviously the recipient. Okay. This is very important for this letter. We will add the source location. And so where the letter is being written from, and then we will add the destination location for the letter. So I'm clicking this. You can see that. Okay, close. You can see that they are coming onto the chart beyond them, and then we can rearrange on here as well anything else you should add. Let's say that I don't know. Okay, let's add the mentions and the subject. Mention. Oh, and subject. We are displaying the most important information for our letter data, and then this allows whoever is looking or viewing the project to see the data that we are working with. So it's ordered in a chronological order by letter data, and again this allows them to see which particular letter we are talking about. You know, who it's when it's written, who it's from, who it's to, where it's coming from, where it's going, what the letter talks about, and then who the letter is mentioned. Those types of things, and you can always add more if, for example, someone is really concerned about where can find the text of this letter. So you can add like a bibliographic information, right? But let's put that at the end, because not many people may want to look at. So going here, bibliographic information at the end can tell you which critical text will have the text of the letter that you are looking for. Okay, so we have used the map, the graph, the table. So as my data set is very, very, very poor, now I want to use the sample data by Palladio. So click on try simple data. This is people and place. You can, if you download, you will see that spreadsheet. So people. Well, these people. Okay, it's the same. We are going to copy and paste. And load something. Perfect. So now we can look at the gallery. This is a really cool presentation tool where we are going to base it on the name of every body. The name, title, the name. We can choose, click on name. We are going to include as their subtitle to any position that they have, and again, these are, it's very important, these are all columns that I had in the data set. So choose position, close. You can see aristocrat, for example. can choose, for example, birthplace or gender. You can sort. You can sort by, let's say, birth date. So we can go youngest to oldest. You can choose picture and image or pictures. You can sort by a name. Okay, it's better. So this gallery mode allows you to visualize who is involved in our project. So those are the 4 basic presentation tools you have with Palladio. You can, as we have seen, you can map a graph, table, or this gallery section. All of them are significant for the type of project that we are doing. So we're going next take a look at different facets. So you can organize the data and only look at one particular subset, depending on what you are trying to do. To begin manipulating the data, we will go down the bottom to this bottom bar there. This is the filters bars. There are 3 different types of filters that we can use in Palladio to isolate or manipulate data facet, timelines, and time spans. So a facet filter allows us to manipulate different of data and a number of different ways. So create, click on facet, create a facet filter allows you to filter to a subset of your data. So you may filter by any of the various dimensions within your data. So it's usually usually not to apply more than I don't know 4 or 5 elements in any single filter. So it's possible to label each facet filter, the description field. You select the dimension. Field, the count field is only one count dimension, number of titles. In this case, for example, we are filtering based on the individual's positions and gender. So click on dimension. For example, position and gender, only 2, close. And you see, you can clear clear any selection already made. Clicking. So in this case, the position and gender phases. When you have selected the dimensions to filter, you can narrow down your data by selecting specific elements. For example, in this case, we are filtering down, I don't know, aristocrat, you see, and financier, Note that as soon as an element is selected or manager, you see, okay, the map or in this case gallery mode, gallery section or the other visualization will update dynamically. So for each facet you can also check to select all or deselect or remove one dimension from the filter. Okay. So timeline filter. A timeline filter allows you to filter to a subset of your data. You may filter by any data elements associated with dates, and can filter by one or more sets of dates. It's possible also in this case label each timeline filter in the description. Choose the date to filter in the date field. For example, okay, birth date. And the height indicates what to count for the height of each bar in a timeline. We have in this case only numbers untitled. And you group by, for example, name. So just a moment. Choose, for example, date. So see. The time span, how to create a time span filter. So time span, no, sorry, this. Time span allows you to filter to a subset of your data. You may filter by any data element associated with the date, and can filter by a data range. Example, per day and that of that. And you can group by, for example, name. You have different possibility of layout, so bar or parallel or grouped bar. Okay, it's late, but I want to just mention other network. Sorry. Okay. Other network visualization tool to consider. So we have many network visualization tools. The easiest is Palladio, but we have not got similar to Palladio in that it makes data collection, mapping, and graph visualizations in easy way. Node XL, easy to use, open source. Gephi is very useful. It's open source, and it's most versatile visualization tool. But I think that expect a step learning curve. I don't know. to say. Another useful tool is VanMaker, and Uniset, Pyet, and it's very important for Python users, the very well documented package Network-X. That's a great starting point for network analysis. So thank you very much for your attention.